Hello friends, welcome to Maths Nerd.
Today, I will teach you about the midpoint theorem and its converse. So, the statement of the midpoint theorem is the line segment joining the midpoints of any two sides of a triangle will be parallel to the third side and half in length. So, let's say that we have a triangle, this triangle, and let's say that mm, this yellow line divides this red line into two parts which are both equal, and the same is for the blue line, that is this part is equal to this part. So we can say that uh, by seeing this we can say that this line is parallel to this line, that is both yellow lines are parallel, and this line, the shorter one, is the half of the longer one, that is this length is equal to this length. Okay, let's see the proof of this theorem. So we have a figure. This is our original triangle ABC. Then E and F are the midpoints of the sides AB and AC, and we have joined them and extended the line, and the line DC is a line parallel to AB, and it is also extended. Now let's write what we know. So we know that AE is equal to BE since E is the midpoint, AF is equal to FC since F is the midpoint, and AB is parallel to CD that we have drawn ourselves, so we know that. Now let's write our first statement. Angle AFE, that is this angle, is equal to CFD, that is CFD, that is this angle. These both angles are equal since they are vertically opposite angles, that is they are formed by two lines intersecting and they are opposite to each other. Now we'll write next statement, that is AF is equal to FC, that is already given here, and we'll write angle FAE, that is this angle, is equal to angle FCD, this angle. They both are equal since they are alternate interior angle to parallel lines, that is these lines are parallel and this line is a transversal, so they are alternate interior angles. So from these three statements we can write that this triangle AEF is congruent to triangle CDF, that is using ASA congruence rule, because AF is this angle is equal, this side is equal, and this angle is equal, and the same for this triangle. So after this we can write that AE is equal to CD, this is equal to this, and EF is equal to FD, this is equal to this, because they are corresponding parts of congruent triangles. So from this we can find that CD is equal to BE, CD is equal to BE, because AE is equal to BE, which is already given, and AE is also equal to CD, so CD is equal to BE, and BE is parallel to CD, that we already know because these two lines are parallel. So we can write that this thing BEDC is a parallelogram, because when two opposite sides are parallel and equal in a quadrilateral, then it is definitely a parallelogram. So we can conclude that EF is parallel to BC. So this is the first part of the statement of the midpoint theorem, while the second part is that EF is half of BC. So we'll prove that using EF is equal to FD. So we know that BEDC is parallelogram, and ED is equal to BC. ED is equal to BC because they are opposite sides of parallelogram. But EF plus FD is equal to BC. BC because EF plus FD is equal to ED. that is, ED is formed by EF and FD. But since ED is equal to BC, we can write that EF plus FD is BC. But since EF is equal to FD, which we have already proven, so 2EF is equal to BC. So EF is equal to 1 by 2 BC, which is exactly what we required. Now let's see the converse of this theorem. So if a line is drawn through the midpoint of one side of a triangle and parallel to other side, it bisects the third side of the triangle. So let's say we have this triangle where if a line is drawn through the midpoint of one side, let's say that this red side is bisected by this yellow line, that is this part is equal to this part, then and it is parallel to the other side. Let's say that this bigger yellow line is parallel to this line, so it bisects the third side, that is this blue side. This part is equal to this part. So let's prove it. We'll use the same diagram which we used in our previous proof, and we'll write what we know this time. So this time we know AE is equal to EB. We also know that EF is parallel to BC, and we also know that AB is parallel to DC since we ourselves constructed it. Now we'll start by first trying to find the congruency between these two triangles. So BEDC is parallelogram. So BE is equal to DC, which means that AE is equal to DC2 because AE is equal to BE. So we can write AEF is equal to FDC because they are alternate interior angles, and the same for EAF is equal to DCF. These both angles are equal. So we can, again using ASA congruence rule, we can write triangle AEF is congruent to triangle CDF. That said, now we will write AF is equal to FC. This AF is equal to FC, which means that F is the midpoint of side AC, which is the third side. Thus, we have proved the converse of midpoint theorem.
Feel free to ask your doubts in the comments. Thank you for watching this video. Please like and share this video and don't forget to subscribe my channel for more videos.